Hello students, we will get into the concept of Buckingham theorem today. Um, the Rayleigh theorem has actually limitations with respect to the number of variables that are involved in a particular phenomenon. To find out the relationship between the dependent and the independent variable, when the independent variables are more in number, that is basically it is more than the dimensional fundamental quantities, fundamental dimensions that are involved in the phenomena, then the Rayleigh theorem becomes very cumbersome for the usage. So Buckingham theorem is a better solution to find out the relationship between variables. Now to use Buckingham theorem, we have to understand some of the important terminologies. Now, what does this theorem tell actually, or what it states? It states that if there are n variables, that may be an independent or dependent variable in a physical phenomena, and if these variables contains m fundamental dimensions, okay, we mean fundamental dimensions as m, l, t, maybe theta for temperature, then the variables are arranged into n minus m dimensionless terms. Each term is called phi term. See, this is why it is called Buckingham theorem. We define something called phi term, which is dimensionless in number, and the number of phi terms is equal to n minus m. Now what is n? N is the number of variables in the process, and m is the fundamental dimensions of those variables. Okay, so n minus m is equal to pi terms. This is a very important step or a statement of Buckingham theorem. Now if you go on defining the things over here, let x1, x2 and x3 to xn be the variables involved in the physical problem or a process. X1, for the moment we define x1 to be a dependent variable and all the others from x2 to xn are independent variables. Now to make it more clear, for example, see in the previous what you can say example, if we take it out here, see here the resistance to the motion is a dependent variable and all the others are the independent, like density, viscosity, length, velocity, right? All these, acceleration due to gravity, all these are variables. Here your r is the dependent variable and all the others are independent variable. Fine, to understand the variable context over here. So you are defining a dependent and an independent variable. So we are taking x1 as a dependent and all the others till xn from x2 to xn are independent. We define a function where x1 is a function of the variables that are involved, that is from x2 to xn. The equation can also be written as f1 as a new function we define of x1 till xn is equal to 0. Now the equation, just now what we have defined, this has to be a dimensionally homogeneous equation. To check homogeneity, we have seen it in the previous example before the Rayleigh theorem. That's how we check the homogeneity, where the powers of the fundamental dimensions has to be equated. Okay. So if this is a homogeneous equation, it contains n variables, right? It has an n variable from 1 to n, right? N variables are there, and if there are m fundamental dimensions, according to Buckingham theorem, you will have dimensionless terms, that is pi terms, which is equal to pi n minus m. So from pi 1, pi 2, pi 3, pi 4, go on like that till pi n minus m terms you will get it. So number of dimensionless terms will be n minus m, number of pi terms. Fine. Each pi term is dimensionless and it is independent of the system. Any division or multiplication you do, it will not change the character of pi term. Each pi term will contain m plus 1 variable. Very important. When we solve problem, you'll understand it in a much better manner. here m is the fundamental dimensions, number of fundamental dimensions. Okay, and each pi term will have m plus 1 variable. So this is called, okay, this is also called as repeating variable. This is very important. Okay, repeating variables are the core for Buckingham theorem. So let us discuss the same case over here. See, what is going to happen is, let in the above case x2, x3, x4, let us consider these are the repeating variables. If the fundamental dimensions, that is MLT or m, small m, is 3, then each pi term, you can write this each and every pi term, okay, from pi 1 till pi n minus 1 as like this. Okay, it is x2 to the power of a1, x3 to the power of b1, x4 to the power of c1, okay, into x1. Similarly, x2 to the power of a2, x3 to the power k2, 3, 4 involvement powers are varied till n minus m. You can write it. See, x2 to the power of n minus m. The powers are changing over here. Okay, accordingly with respect to the terms. Okay, from x1 till xn, you can actually continue. Okay, we cannot involve x2, x3, x4 here because they are considered here as a independent variables. So each of the equation is sorted for the dimension homogeneity, and the values of a1, b1, c1, all the values have been. So you will be knowing the value of pi 1, pi 2 up to pi n minus n. That you will obtain it. And finally, an equation you will write it. Final equation for phenomena is expressed in one of the pi terms as a function of the others. That is, pi 1 is a function of pi 2, pi 3 to pi n minus n, or pi 2 is a function of pi 1, pi 3, pi n minus n. See, there is a basic method to select the repeating variables. The number of repeating variables has to be equal to number of fundamental dimensions of the problem. The choice contains, or you need to remember, or you need to consider so many things. For example, see, as far as possible, the dependent variable should not be selected as a repeating variable, so you cannot select dependent variable as a repeating variable. The repeating variable should be chosen such a way that one should be from a geometric parameter. That is, either it should be a length, diameter, or height. These, okay, length, diameter, height is telling something about the geometry, right? It's a geometry variable. One of the variable you should consider it from the flow parameters or the flow properties. That is like a velocity, acceleration, that defines or that connects with the flow. One of the variable you should connect it, or you should consider it or take it from the fluid property, like viscosity, density, maybe the angular velocities, such kind of angular acceleration, such kind of things you need to consider. So basic thing is, one variable should be from geometric parameter, one variable should be from flow parameter, one variable should be from fluid property. Okay, the repeating variable selected should not form a dimensionless group. The repeating variable together must have the same number of fundamental dimensions. No two repeating variables should have the same dimensions. So if I consider your mu, and if I consider velocity, the dimensions of mu and v, velocity v, should not be the same. That is very important. We need to consider. See, for example, choice of the repeating variables, you can make it like this. Like, consider diameter connected with geometry, consider velocity with flow, and density. This is the fluid property. This is fine. Or length, velocity, and density is also fine. Or length, velocity, and your mu is also fine. So the consideration is very important. Which are the repeating variables that you will consider? Which are going to repeat in all your pi terms. Okay, from pi 1 till pi n minus n, you will repeat and you will work on that. Okay, this is the introduction to Buckingham pi theorem. I know you have so many doubts in your mind. Please post it in the WhatsApp, or you can connect with me in the Google Classroom. Okay, the important thing here is, okay, you will understand it in a much better manner when we start solving the problem. Okay, Buckingham pi theorem is not a difficult, what you can say, theorem. It can be done very easily. Thank you very much.